Welcome to your video on electronegativity. Give you a little introduction to this concept, which is going to stick with us for a little while here. Jumping right into it, I'll give you a nice little textbook definition. It's going to be a tough one to wrap your brain around maybe at first. Why it's useful, what it is. And one of the reasons for that is it's dependent upon a couple of things. So here's the basic definition. It says electronegativity is the ability of an atom to attract electrons to itself. So we're talking about an atom and pulling electrons that are outside of it into it, like a tractor beam. So it's dependent upon two things. I'm going to write them down first, and then I'm going to elaborate on it. One is atomic number, also known as the number of protons. The second thing it's dependent upon is atomic radius, which we've recently worked with. Alright, so let's see. Just slide this down. I'm going to elaborate on this a little bit. So remember this definition, the ability of an atom to attract electrons to itself. Alright, so why is atomic number, aka number of protons, important here? Well, to hope to show that, I'll give you a little drawing. So here's the nucleus, and here's one shell, and here's another shell. Again, this is a Bohr model, and I always kind of need to make that disclaimer that this is not how science currently views the atom. I got a couple of electrons flying around there. Got the positive nucleus, and what we're talking about is the ability of an atom to attract an electron into it. So say you got an electron that's kind of flying around out here, and we're saying, will the nucleus exert electromagnetic attraction on that electron such that the electron will get drawn into the atom? Well, hopefully it's kind of obvious why atomic number, also known as number of protons, plays a role here. We know that the greater the charge, the greater the attraction. So if the nucleus has more protons, that means it's going to be more positive. That means the electromagnetic pull that it's able to exert on this electron out here is going to be greater. So the greater the charge, the greater the attraction. So that kind of deals with why atomic number is important. You got more protons, you got more positive charge. It's going to be better at pulling an electron into the atom. Opposites attract. Alright, the second thing that it's going to depend upon is atomic radius. So we know atomic radius is the distance from the nucleus to the outside of the atom. So atomic radius would be roughly this distance here, right there. So if what we're talking about is the nucleus trying to exert a pull on an electron that's just outside of it, the size of the atom makes a difference. We know that from an electromagnetic viewpoint that the force of attraction decreases with distance. So the ability of the nucleus to pull this outside electron is going to be worse. It's not going to be as powerful if the atom is bigger. So force of attraction decreases with distance. And again, this is basic electromagnetism. You increase the distance, the force of attraction, the opposites attract force is going to lessen. So it's the difference between having an atom like the one you see here and having one that has, say, let's see, another shell on it, and instead of the electron that is in question being here, it's rather going to be out here. So since this electron is farther, because this atom is bigger, the force of attraction is going to be a little less because it has to cover more ground. So those two factors, atomic number and atomic radius, play a big role in electronegativity. So just to recap the basics, electronegativity is the ability of an atom to attract electrons to itself. Atomic number is important because it tells you how positive the nucleus is. The more positive it is, the more force of attraction it can exert over a negative electron that's outside the nucleus. And then also, atomic radius is important because the farther the nucleus is from the electron that it's trying to pull in, the less electromagnetic attraction it's going to be able to exert on it. And as a last little thing, if you look on your periodic table, you'll find that those green ones that I gave you actually have electronegativity right on there. And we're gonna work all that stuff out in class, but those are the basics.